Good morning. Good morning. Hope all is well. Hope everyone is doing all right. Good morning. Good morning. Hope you had a great weekend. Ready to get this one rolling. Good morning. Good morning. All right. I think everybody's in. Looks like it. All right. So today we're looking at six. We may be able to do both sections. We'll see. Then we got to talk about how we're going to close out going into spring break. So spring break is the week after next. So I know you guys are looking forward to it. All right, so 6.1 probability distributions are models of random experiments. All right, so a description of how a statistician thinks data are produced is the probability model. So probability distribution, sometimes called probability distribution function, PDF. All right. It's a tool that helps us by keeping track of the outcomes of random experiments and the probabilities associated with those outcomes. All right, so it tells us all possible outcomes and it tells us the probability of each outcome. As always, if I scroll up too far, let me know. Everybody hold on to black. All right. So discrete outcomes are or discrete variables are numerical values you can list or count. Continuous variables or continuous outcomes cannot be listed or counted because they occur over a range. So we'll talk about what that means in a second. All right. So the key to continuous outcomes is that they're weighted or measured. Anything that's weighted or measured will be considered continuous. So, and we're about to see some examples of the difference between discrete and continuous. So when it comes to discrete, if you can count it and there's no deviation from that counting, then it's discrete. So what do I mean by that? If you count the number of people, if there are 5 people in a classroom, there's no such thing as 5.1 of a person or 5.5 people. So it's either 5 people or it's not. It's 5 people, it's 6 people, it's 7 people. So that's discrete. When you can count it and there's no range, it's either it or it's not. That's discrete. Continuous, whenever you're measuring or weighing something, that's when you have continuous variables. So let's say you're weighing a sandwich or you weighing anything and it's 5.1. My scale says 5.1. Your scale is more accurate and it's 5.12. Someone else's scale is more accurate than that. It's 5.123. Well, all of those are the same thing. All of those are correct. It's just that your scale is more accurate than my scale, which is more accurate than the next scale, or so on. So that's the difference between discrete variables and continuous variables. All right, sorry about that. I had to answer one of your classmates. All right, so discrete or continuous. So the first one, the weight of a sandwich at the deli, once again, is weighted scale, so that will be considered continuous. Your accuracy on grams would dictate what your answer is, and they all would be still correct if your scale is correct. All right. The number of people in the car beside you or passing you, that will be discrete because there's 3 people or there's 4 people, but there's not 4.1 people or 4.2 people. All right, so that's going to be discrete. Anyone holding on to continuous? All right, the blood level of a driver pulled over by the police in a sobriety check, that's going to be continuous. Once again, that's something that's measured. And then D, the number of eggs laid by a chicken is discrete because there's no such thing as a decimal value or a fraction of an egg. It's just an egg. Any questions? Any questions? Any questions? Or we go to the next one. So now this right here was an example I saw in math lab. So I believe it was in math lab. So I want to make sure we're okay with what it's asking of you. So everybody okay with C and D? All right, so it says give the table that shows the probability distribution for the amount of money you will win. Draw a graph of this probability distribution function. So they give you these details and then they give you the option of graphs that you would choose from. Of course, you wouldn't have to draw it yourself. They just give you A, B, C, D. and then you would choose from that. All right, so it says roll a fair six-sided die. You will win $4 if you roll a 5 or 6. You will lose $5 if you roll a 1. For any other outcome, you will win or lose nothing. I'll give you a chance to write. All right. Everybody done with the black part? All right, so in red, I just wrote down the 3 major outcomes that we have. You're going to win $4, lose $5, or win 0. All right, sorry about that. So scroll up, talking about when these occur. So 5 or 6, when you roll 5 or 6, you win $4. That's 2 out of 6, which is 1/3. Roll 2, 3, or 4, you win $0. That's 3 out of 6, which is half of the time. Then you lose $5 when you roll a 1. So that's 1 out of the 6. And we're talking about rolling a die. Die is 1 through 6. 5 and 6, which is 2 options out of the 6. That's why it's 2 over 6. Roll a 2, 3, or 4. That's 3 options out of the 6. That's 3 over 6. Roll a 1 is 1 out of 6. Everybody okay? So you just got to take your time and map out, your options, do it in pieces or all at once, depends on how you're processing it. And we scroll up. And so your probability chart or distribution chart will look similar to this. Now your dollars down bottom, -5 to +5. Then over here, up on this left, you have your probability. Any questions? Any questions? That probability, over here, I got the decimal value. 1/3 is 0.3 repeated. Half is 0.5. 1 over 6 is 0.16. So the dots go up to about that. $0 goes all the way up to just 0.5. The -$5 goes close to 0.2. That's at 0.16. And then here, winning $4 goes up to close to 3.5, but 3.3333. Questions? Any questions? Can I scroll up? That's it for 6-1. All right, the normal model. We talked about this in the beginning, and I said that it's going to come back. We're going to be dependent on it moving forward. Your normal model, the bell-shaped curve, is the most widely used probability model for continuous numerical variables. The curve used to visualize this is called the normal curve or normal distribution. And that's that right there. Your mean is in the middle, and you have that bell-shaped curve. The bulk of your data is in the middle. And as you go away from the middle, go away from the mean, go away from your average, it gets less and less as far as your data is concerned. All right. So we have our Greek letters. Mu is going to be the mean of our probability distribution. Lowercase sigma, standard deviation of our probability distribution. So we've seen these letters before. A few more details. Normal distribution is symmetric about the mean. That means your mean is in the middle. 50% of your data is to the right of your mean. 50% of your data is to the left of your mean. Everything that happens on the right happens on the left as well. So that's what it means being symmetric. It is unimodal and bell-shaped. Means it only has one mode. And the notation is going to be in parentheses, mu, comma, sigma, and that tells you what your mean and your standard deviation is. So if you see this notation, that means that your mean is 75, your standard deviation is 3. So that's all that means. Just a shorthand way using symbols to let you know the information. Any questions so far? Also, this statement right here, I believe it's something that MATLAB asked. The standard normal model with the mean of 0 and a standard deviation of 1. So they ask you about the standard normal. The model has the mean has 0, has the mean of 0, standard deviation of 1. right. Z-scores. You're getting more into Z-scores now. Something that we'll use to convert to a standard way of looking at data. It converts data values into how many standard deviations there are. They are from the mean. All right, so the formula is your data value minus the mean divided by the standard deviation. And we always round our Z-scores to 2 decimal places. After Z-score is found, you go to your Z-score chart to get the probability. That's going to be on pages A2 through A3 in the back. The appendix pages. All right, sorry about that. Trying to pull up my chart. Can we scroll up? All right, so let's look at using the Z-score and the Z-score chart. It says small newborn seal pups have a lower chance of survival. Suppose the length of a newborn seal follows normal distribution with a mean of 29.5 inches, standard deviation of 1.2 inches. What is the probability that a newborn selected at random is shorter than 28.0 inches? Give you a chance to write that down for those who are doing so. All right. So write down your given information first. Our mean is 29.5, standard deviation is 1.2, and our data value is 28. We're talking about shorter than 28. So we're looking at 28 being our data value. Whatever we're doing our comparison to, whether it be shorter than, greater than, between, that's our data value. You see over here, I put it in the formula, x minus mu over sigma, data value minus your standard deviation over, your data value minus your mean over the standard deviation, excuse me. And we get negative 1.25. Everybody okay so far with step one? Okay, I'm going to actually show you the chart in a second, but I wanted to show you how to read it first before I switch to switch screens. Let's scroll up some more. All right. So when we go to the chart on this left side, is anybody still copying this? All right. So there's a left column right here, and then a top row. And that's what's going to help you to find your value. Notice our value is negative 1.25. So if you notice right here, I said you're going to look for negative 1.2 on this column right here, this far left column. Then we look for the 5 up here on the top row. Then we go into the chart and see where they meet. And that is the value that we pull from the chart. All right, so now before I go to the chart, is everybody okay with what I've said? We have negative 1.25 as our z-score. Our last value, that 5, is what's going to be up here. And then everything before it will be over here on this left column. Okay, so erase this. So this is how it looks. And like I said, it's in the back of your book. I probably will send you a copy of this. You just have to remember to do so. Just so if you want it outside of the book, then you'll have it. All z-score charts are not the same. So in other words, if you were to Google z-score chart, you may get one like this. Or you may get one that's different. There's like 2 or 3 different z-score charts, maybe 3 or 4 different types of z-score charts. They all give you the same value, but you have to know how to read them. And so the way this one reads is like I'm telling you, wherein you go here, where's my writing? Okay. Negative 1.2 is over here to the left. 0.5 is 0.05 is up top. And then where they meet is the value we're going to pull from the chart. And so it's 0.1056. So questions on what we did just now? All right. Also notice they give you this. Now this is the negative. The second page is the positive. Those all these values are positive, but it still gives you, it tells you that this z-score value that you're pulling, this chart value represents everything to the left. So, or represent less than. So let's go back to our notes. And so that's what I said right here. The chart value is always less than or to the left of your z-score. So that's going to be key when you talk about keywords. And so that's what I'm saying right here. There will always be a key phrase that will let us know what we're going to do. So I'll give you a chance to write that before we go further and we actually interpret what this value means to us. All right. So shorter than is the same thing as less than. So like I said, you're going to get key phrases that's going to dictate what you do. First one that we're dealing with right now is shorter than, less than, lower, under. Those are the same thing as far as the phrase is concerned. And so that means that this chart value will represent that. Less than and to the left of, will all represent the same thing. If it was greater than, then it would be to the right of. If you think about your number line, if you have the number one, everything that's greater than number one will be to the right of it. Everything that's less than it will be to the left of it. So less than will always be to the left of. Greater than will always be to the right of. All right. So this means we will use the chart value. Once again, less than, the chart value always represents less than. So that means you're going to use the chart value in this case because we were talking about fewer or shorter. Let me go back to it. Shorter than, we're talking about shorter than, which is the same thing as less than. So the conclusion is that the probability that a newborn seal will be shorter than 28 inches is 10.56%. All right, questions on what we did there before we look at the next one. There are only 3 key phrases that you have to deal with. The first one is less than. All right. You scroll up. So what is the probability that a newborn selected at random is longer than 32 inches? Key phrase here is going to be longer than, which suggests greater, excuse me, which is the same thing as greater than. All right, so we take the information from the problem. 32 is going to be X because we're looking at 32, comparing 32 is longer than. We're still using our mean and standard deviation from initial setup of this problem. So mean is 29.5, standard deviation is 1.2. Put it in our z-score formula that ends up giving us 2.08. Don't forget, always round to 2 decimal places. And the reason why we're doing that, remember the chart, if you go back to the chart is in 2 decimal places. So that's why we always round to 2 decimal places. And then from there, use the chart in the same fashion. So let me go back to the chart, show you again. Just want to make sure I emphasize the process. So now we're looking at positive 2.08. All right, 2.0 is right here. 8 is up here. So then you just go and see where they meet. And it's right here, 0.9812. All right, so everybody okay with what we just did? Okay. And so that's what I was simulating here. Now, step 3, our problem said longer than, so that means we're looking at greater than or to the right of. Remember, less than was to the left of, greater than is to the right of. So the chart value always represents what is to the left of. Always represent what is to the left. I think represent was fine. So the chart value always represent what is to the left of. So to find what is to the right of, you subtract the chart value from 1. So everything under the curve is equal to 1. Remember I mentioned before that 50% of your data is to the right, 50% is to the left of your mean. So 50% plus 50% is 1 or 100%. So if I know 0.7 is to the left of, in order to find what is to the right of, I subtract it from 1. That means 0.3 is to the right of it. So if you know what's to the left of your data value, you can always subtract that from 1 in order to figure out what's to the right of your data value. So once again, the statement right here, if you're trying to find out what is to the right of your data value, you subtract the chart value from 1. And that's what I was saying right here. Everything under the curve is equal to 1. So that's why you can just subtract stuff from 1 to find out what's on the other side. All right. So perform that task right here in the green one, minus 0.9812, 0.0188. Probability that a newborn seal will be longer than 32 inches is 1.88%, or about 2%. All right, any questions, any questions? All right. Like I mentioned, there are 3 scenarios that you could come across. So this is the third one. We're talking about less than, greater than, and then between. So this is our third one, between. What is the probability that this randomly selected seal will be between 27 and 31 inches long? So if it's between, that means you have 2 data values that you have to convert to z-scores. Our mean and standard deviation are the same, but I'm gonna call 27 data value 1, call 31 data value 2, and we find the z-score of each one of them individually. So 27 ends up converting to negative 2.08, and then 31 converts to 1.25 as z-score. Mm-hmm. Give you a chance to finish writing that down. All right, are we good? So now that you have 2 z-scores, that means you need 2 chart values. So you go to the chart for each one of those individually and find your chart values. For negative 2.08, we ended up getting 0.0188. And then for 1.25, we end up having the chart value of 0.08944. All right. So here's just a diagram of, or just to give you a vision as to why we're doing what we're doing here. All right, so that first z-score gives us that 0.0188. Z-score 2 gives us 0.8944. So now both of them are to the left of their respective values. But if I want to know what's between, then I can subtract this from this, and that'll give me what's in between, this red right here. And so whenever we have between, that's what we're going to do. We find our z-scores, then we find our chart values, then we subtract the chart values from each other. So notice the warning here is that you do not subtract your z-scores. Sometimes people make a mistake and subtract z-scores or perform calculation with z-scores. We do not perform any calculation with z-scores, just like you don't subtract your z-scores from 1. You get your z-scores, you go to the chart, get your chart values, then you subtract your chart values. All right. So that 0.8944 minus 0.0188 will give you 0.8756. All right, any questions before we scroll up? All right, so the probability that a newborn seal will be between 27 and 31 is 87.56, or about 88%. All right, any questions before we summarize everything? All right, so the summary, there are only 3 scenarios: less than, greater than, and between. And notice that those are the outcomes that you perform if you have those 3 scenarios respectively. So if it's less than, you use the chart value that comes out of it. If it's greater than, you take that chart value, subtract it from 1. If it's between, you're going to subtract your 2 chart values from each other. And so there will be keywords that will dictate, less than, greater than, or between. Well, between is pretty much between. I haven't seen another word that they've used other than between. But for less than, you got shorter, below, colder, under, something along those lines. Greater than, talking about longer, taller, above, hotter. So anything that signifies that. I'm pretty sure there are other ones out there, but just keywords that will let you know that the scenario that you're dealing with is less than, the scenario that you're dealing with is greater than. And if it's less than, you're going to use the chart value that you get. If it's greater than, you're going to subtract that chart value from 1. And then between, you subtract the 2 chart values that you have. All right. Questions. Then we got one more thing in this section, and then that'll be it. Can I scroll up? Let me see something real quick. Yeah, that's it. Thought so. All right. Everybody done with the keywords? All right. So last thing in this section, percentiles. The kth percentile of a set of data is a value such that k% of observations are less than or equal to the value. K% should be is less than. Yeah, it should be is less than. So Jennifer just received the results of her SAT exam. Her SAT math score is 600. Of 600 is in the 74th percentile. What does this mean? All right. So this means that 74% of the people who took the exam scored 600 or less. 26% scored better. Questions. All right, can I move on to another page? If somebody's still copying. All right, so how are we going to operate moving forward? So the next two classes will be review days for you guys to ask whatever questions you want to ask. If you don't have any questions, then it's not mandatory that you show. But on next Wednesday, we have to, now, we're not doing, I haven't mentioned any midterms. We're not doing any midterms or anything like that. But next Wednesday is the last day before, it's called spring break. Okay, and I have to proctor something at some point. Up to this point, you guys have taken your first two tests unproctored. You're doing them on your own, which is fine. But at some point, by requirement that I do have to proctor a test, see that it's you that's taking it, something along those lines, because really the way things have been set up to this point, saying most of you haven't enabled your camera, which is fine. Most of you haven't seen any real legit evidence of you doing work. So really you could have your cousin from down the street knocking all this stuff out for you, right? So we have to at least simulate the classroom process, the face-to-face process in some fashion. So we're going to have options for this next test. Okay, so we're going to have a proctored option where it will be during this class time, which is next Wednesday, May 2nd. It's on well, I'll just write it up here. Well, chapters 5, 6. So you're talking about 5, 1, 5, 2, 5, 3, 5, 4, 6, 1, 6, 2. So the test review is already posted. You should see that. You already have access to that. So you know what type of problems will be on the test. It will be a scenario, and I'm going to email you guys directions on how we're going to do it. Same things I'm about to say to you right now. So you come in, enable your camera, show your ID to the camera. I'll give you the password. You log on and take the test. So it's going to be in Math Lab, but it's only going to be during the class time. So it will be proctored, and that's how we do it. And I'll sit and I'll just be watching you as if we were in the class time, class period, face to face. The other option that will occur is after we have that day of proctoring, the test will show up in Math Lab as well. You can do both of them. You can do just one of them. Whatever way you want to do it is up to you. The only catch is that for the Math Lab option, when you're doing it on your own time, the highest score you can get on that is an 85. Now, 85 does not stop you from getting an A out of the class, but I do have to put something in there as like a buffer to secure the integrity of the course, the academic integrity, all this stuff like that. So, so at least so that it looks like, there's a legit penalty. So 85 does not stop you from scoring A out of the class, but I do have to do some type of proctoring. So this is my way of helping you and helping me all at the same time. So if you do not have a hard copy, if you don't have a hard copy of your student ID, then hopefully you have a license or some type of picture ID that you can show, and that's good enough as well. And so that's another reason why we want to do stuff like this, so that in the final exam we don't have an option. That whole thing is proctored. That's not an option. Everybody has to take the final exam. So we do want to iron out these details now. So then it will be the same thing. So we do the two. Yep. So it will be during the class time. So that will be the class time limit. So we're talking about 1.5 hours. So if you have accommodations that need to be met, so you'll email me outside of class if you have one of those accommodation sheets, and you may have to take it during, through Johnny Davis and the testing center and stuff like that. But that's something that, that's an individual situation, and, we'll handle that individually. But during class time, you have 1.5 hours. For the final exam, you have 2 hours, a 2-hour block that we'll set aside.
So you said this is for next Wednesday before
Yes.
break?
Yes. Mm-hmm.
Okay.
Yep. So whether you're going to do it or not, you don't necessarily have to let me know. You can just show up. I'm going to show up that day anyway. So I'll show up, and just, who shows up, they will take advantage of this first option and just take the test. So technically you have 3 chances to get the best grade possible on this test. If you want, take it proctored, then you have 2 chances here. Once it opens up, once again, you won't see that option until after we do this proctored test. All right. If you don't show up, then I'm assuming you're just going to take it, in Math Lab on your own time at some point. But like I said, the highest score for that one would be 85. Now, what I'm not doing, just want to make sure I'm clear, I'm not taking 15 points off of your score. What I'm saying is that if you score 95, it's going to automatically be an 85. But if you score 75, it'll just be 75. So like I said, the cap on it will be 85. But I'm not taking, sometimes people interpret that as I'm taking 15 off of whatever you score. That's not what's happening. It's just that the cap that you can get on that on time test would just be 85. Okay. Questions on what I said up to this point? Questions. For the final exam, we'll have a similar option, something like that. But once again, you cannot take advantage of that unless you actually take the final exam proctor. You have to take the final exam proctor. That's not an option. Once again, we'll talk about that more when we get there, but there will be a buffer for you in that regard as well, but we'll talk about that later. What if you take the proctor but don't like the score? Yes, you can. Yeah, if you come in on test day, take it, and you don't like your score, feel free to knock it out again in your Math Lab. Yeah, on your own. All right. Anything else? Anybody else? Any other questions? Like I said, I'm going to shoot you an email with the details laid out, things I've said. If you have any more questions about it, feel free to email me. Have any more questions? We have 2 more class periods when you can ask me to make sure you clearly understand what we're saying right now. I'm just dropping that seed to make sure you know what we're trying to do, getting into going into Wednesday and then going into spring break. So from this point forward, we're not doing anything else new until after spring break. Then we'll get into chapter 7. But this is our proctored thing that we're doing going into next Wednesday. All right. Any other questions, concerns, comments before we close out today? Very good. All right. Somebody said something in chat. What are we allowed to have? Whatever you use for your homework is what you can use for your final exam. I'm not final exam, for your test. So I'm not putting the lockdown browser in, because remember, I've told you guys to use what's the name of stuff? Websites and apps and calculators. You know what I'm saying? I told you to use that. So I'm not, whatever you use for your homework, you will be able to use for your test. So if you have a good set of notes, you'll be able to use your notes. I would actually encourage you to set up a good set of notes because, if you go to the test review, create notes based off the test review, you should be straight for this test. It's just the only thing you have to consider is the time. And so you make sure you streamline and set things up so that you're able to knock out everything within the time constraints. All right. Anything else? Somebody else? Yep, no problem. Not a problem. Anything else before we close today? Okay. So the next 2 days, up to you if you show up. It's up to you to ask questions. I'm not bringing anything to the table. I'm just coming here and then I'm walking through whatever it is you asked me to walk through. So if nothing else, take a look at the test review and see if there's something in the test review that may, pique your interest or have questions on, and we'll go from there. All right. So you guys have a good one. Be safe. I will see you on Wednesday. Take care. All right. Thanks. You do the same.
Thank you. Have a great.
Thanks. You do the same. Take care.